Another interesting demonstration that you can do related to Newton is to show the students Newton's cradle. What is this interesting device? I bet you have seen it, but how does it work? What does it do? Newton's cradle consists of quite a lot of 5 or 7 balls. Each one of them is attached by this string, and those balls act as pendulum. Each one of them, you can see the strings here, and each one of the balls can move, and they also can collide with each other. What can we do with this demo? First of all, we can ask our students, what will happen if we take one of the pendulums, we pull it to the side, you can hold the pendulum here and let go of it. Predict what you think is going to happen. Thought about it? Now let's try. So what have you noticed? The collisions are going for quite a long time, and you can see that the amplitude, how far the balls are going, is going down and down. But you probably also can hear that a lot of sound is created. And it happens because during those collisions, the original potential energy of the ball is converted to kinetic energy at the bottom, and then during the collision, the kinetic energy of one ball is transferred to the other, but a little bit of this energy is converted to the heat and sound. That's why you could hear that. As a result, each one of the collisions transfers some of the energy, and the last ball will go up, but a little bit less than not as high up than the first one. Eventually, all the energy will be converted into heat and sound. This experiment shows you the laws of conservation of energy and momentum. Energy is something that we all deal with. You eat a power bar or an apple, and you consume energy that will be converted to chemical energy inside your body and then heat. In physics here, we're dealing with kinetic energy, the energy of motion, and potential energy related to the height of this ball compared to the lowest part, and the energy of sound and heat. Now this device allows you to do a lot of cool experiments. For example, you can take 2 balls and ask what will happen if we pull 2 aside. I'm holding it so it's not moving. Let's see. You notice that 2 balls are going to the other side. It's always symmetrical. You took one goes up. And what will happen if I pull 3 to the side? Let's try 3. 3 to the side. Now you can see 3 go to the other side. And you can prove this using the laws of conservation of energy and momentum. It's a great experiment to show the students two of the fundamentals laws of physics, the laws of conservation, that tells you that energy and momentum cannot disappear. They will always remain constant. And the only thing that you have to do, you have to account for all forms of energy. In this experiment, it is potential energy at the beginning, kinetic energy here, the energy related to heat and sound. And I keep saying heat because if you touch the balls and measure their temperature after the collision, they will become a little bit higher. And I brought a couple of another one, for example, that you can see, Newton's cradles came in different shapes, so you can play with them with your students.